Alright guys, welcome back. So today we are going to start working on the joinery on our side rails here. So we're going to start by cleaning the epoxy here. We've got it filled up on one side, and then it looks like our epoxy actually managed to flow all the way through to the back side, so I actually don't have to fill that knot, which is kind of nice. So we'll see how much we have to do. We may have to go back in and do some touch-ups there. But again, this is going to be on the inside of the bed that no one's going to see anyway, so I'm not too concerned about it. But I have to say that 24-hour epoxy worked a hell of a lot better than the whatever the deep pour stuff that I was using before. It started to tack up in only a couple hours after I actually poured it, so it was nice and thick, and and I've left it for a couple days now, so it is fully hardened up. You can feel the surface. There's no movement to it. It's nice and dried up. And a quick update on the other board, it did start to drip when we added the 24-hour epoxy. You can see we got a whole new bulge in here now. But because it was able to tack up a little bit faster, we lost a lot less epoxy. I didn't have to make any more. And now this knot is finally filled. So when we get around to milling these, it should be a lot easier. Although this board in general is just going to be an absolute nightmare because we got a whole ton of tuck tape we're going to have to cut off somehow. So starting to cut into this epoxy here, it is clearly not dried yet. So these are some of the shavings. And so epoxy shavings, when you cut into them, they should come off like a shaving of anything else. They should just slide through the plane. The plane should just slice right through it. You can see here how these are still, stretchy and sticky, and I can mold them and stick them back together, all that. That tells me that the epoxy is not fully cured. So what we're going to do is we're just going to leave the epoxy for now because we can do everything else we need to do to this board with the epoxy on here. This isn't really going to affect anything. I was just planning to come in this morning and clean it up just to get it out of the way. That also made me go back and check this other board here, and you can see on the side, if I just push on a little bit, we are still quite squishy, which means that the epoxy has not at all cured in the middle area. And on the surface, if I press right where the knot is, it's actually still kind of squishy. So this one is going to take quite a while to actually get around to. So we'll have to see how long it takes. So when it comes to cutting our joinery, we know that our ends are not perfectly squared up. So we can't use like a marking gauge to cut a line in. So what we're going to have to do here is take most of our references off of our edges here because we now know that they are, again, mostly parallel. And our end here is, for the most part, it's actually pretty good. Now, I won't say it's perfect. There's definitely slopes to it. It's not great. And like I said in the previous video, this face here doesn't really matter for, being perfectly square to the sides of the board here because that's going to be the ends of our tenons. It's not that big of a deal. So from the same reference points on both sides of the board, we're going to mark in 1 3/8 of an inch. We can then use our handy little straight edge that we made, mark a line across, and that will be the line that we're going to work to on both of these. And so a big part of this is going to be fitting up these tenons once the actual bed frame is really put together. So once we have the tenons cut on the rails here, we can then transfer those tenons over to the legs. We can then cut the mortises on the legs. Then once we have the mortises in place, we can then true up the tenons on the rails. So it's going to be a lot of back and forth trying to get these things fitted up. And so the big thing here is I just want to start with the rails because I think that that's going to be the easiest place to start here. Shop tip, if you're noticing that your router is a little bit stiff on its vertical movement now, when you're adjusting the depth of it, get some of this WD-40 dry lube. So it's dirt and dust resistant, and all you're going to do is just take a little bit of it and just spray it on the inside here. Now with this Bosch MRP router, you want to make sure that you're not spraying it on the electrical contacts, but if you just make sure that you get it on the inside edge there, what this will do is it'll just make it so the motor is actually able to adjust nicely. Okay, so we've got the first side of our tenon cut. This is the back side. I made sure to start with it because it's never going to be seen once the actual bed is put together, so it doesn't matter if I screwed up slightly. So overall, I think this idea is actually going to work out pretty well, because what we're going to be doing is cutting down 3/8 of an inch on both sides. Because we have 1 3/4 thick boards, that's going to leave us with a 1-inch tenon running through the middle. Now these tenons might look a little bit short at 1 3/8 of an inch here, but I promise you they're going to be in more than enough strength, because for the most part these are just for alignment. Because we're going to be mounting these into some mortises that we're going to cut into the legs. Then we're also going to be adding in a 1/2-inch bolt right in the middle here that'll actually pull everything together. So it's going to be a very solid connection, and just with how thick and how beefy these tenons are, they're going to be plenty strong enough. I have zero worries about them. The one thing that is going to be very annoying with this process, though, is not having this end grain here squared up. Because what I'm finding is that on the bottom side here, where I took all my measurements from, we're at precisely 1 3/8 of an inch. Whereas at the top here, we're about a 1/16 over 1 3/8 of an inch. So 1 7/16. So we have a 1/16 of an inch difference between here and here. The one nice thing about the way that we're doing this is that the shoulder of our tenons here is actually perfectly squared up to the edges of our board. So we do have a perfectly straight and perfectly square surface now, so there shouldn't actually be anything to fix up here. Because we're taking all of our references from one side of this board, it means that everything is coming out perfectly. So all this is going to affect is that when we cut our mortises into our leg pieces, we just need to make sure we account for that extra 1/16 of an inch length that's going to be at this top side here. I usually leave about a 1/16 to 3/32 of an inch of extra space at the bottom of the mortise, just for glue and squeeze out in that to build up in. So we'll have plenty of excess space in here to account for the difference between these two sides when we actually cut our tenons and start fitting them into the mortises. So now we need to match the side that we just cut to the opposite side that we still need to cut. Okay, so check that out. Our shoulders are pretty much perfectly lined up. We did go a little bit past the line that I wanted to, so they're a little bit longer than 1 3/8 now that I'm kind of checking back there. But our shoulders line up, and that is all that particularly matters at this point in time. This top one is a little bit further in, which just means we might have to touch it up with the hand plane when we do our final fit up, but it's always better to have to remove material than to have removed too much material with the power tools. So we're at a good position here. Again, our shoulders are all nicely squared up to these ends. So overall, even though I don't have any of the proper tools or machinery to be doing this, I'm managing to get something together here. And I say that very lightly because I feel like at any moment now, something's going to go very wrong. But now what we need to do is actually cut in our tenons here. So like I said before, we're going to be doing 2 separate tenons, and then we're going to have a space in the middle for a bolt to go through. Now, one of the most important things is anytime you're building or planning to build a bed, you need to think about how you're going to take it apart. Because obviously you could not put a fully built king-size bed into any normal house in North America, Europe, whatever. And so with the rails like this, we have the benefit of this is a nice chunky piece of wood. And we've got really good grain orientation here in that the grain is running with the wood here. So when we put that bolt in there, and we're going to be putting a square nut a little ways back, that square nut is going to be pulling on end grain. Now, end grain is super hard, which means it's not going to deform over time. And as long as we put that nut far enough back, we never have to worry about it cracking. So it's going to be super simple to just drill a hole through and then put that nut through. And so there's a lot of considerations that have to go into making this tenon. Now, initially what I wanted to do is I wanted to just have one solid tenon along here, because that would leave everything, as strong as possible. You'd mount this whole tenon off this piece of wood here into that footboard and headboard piece, and that's a solid chunk of wood holding everything together. But the problem is we can't do that, because our tenon is going to be going 1 3/8 or 1 7/16 into that footboard piece, which is only going to be 1 3/4 of an inch thick. So we only have about 1/4 of an inch between the end of our tenon here and the outside of that leg piece. So the problem is that in the middle here, where we're going to be installing that bolt, we need enough material to not only support that bolt, so 1/4 inch is nowhere near enough material to physically support the pressure that bolt is going to apply. We also need to be able to hide that bolt, because I don't want it to be visible on that outside edge. I want to be able to bury it into the wood, put a little cap over it so you don't see the silver bolt sticking out. So we need to make sure that we can inset it into the board a little bit. And we can't do all of that in only 1/4 of an inch of material. So now what we have to do is we have to separate this 12-inch long tenon that we have here into 2 separate tenons. So what we're going to be doing is we're going to be breaking this 12-inch long tenon that we have right now into 2 separate tenons. So we're going to be taking a 1/2 inch off the side here, doing a 2-inch opening in the middle, because that should give us more than enough space for our bolt to go through and to give it enough supporting material around it, and then another 1/2 inch off the bottom side here. That leaves us with a 4.5 inch tenon on one side and a 4.5 inch tenon on the other side. So I mean, that's how you know you're dealing with a pretty big tenon, when that's your off-cut middle piece there. That is still a decently sized piece of wood. Okay, so that is one of 4 ends done, and it's actually looking pretty good. So we've got our 2 tenons here. I made sure to go through and square these up as best I can onto the edges here. So I just went through and just checked them very roughly with the square here. Not that that's going to have a big effect on our joinery, but if those ends are square, it's going to be a little bit easier to lay out our mortises on the other pieces. And so I made sure that I was on all 4 of these other edges here. I also went through and touched them up with a file just so they're a little bit cleaned up. We'll touch them up with some sandpaper when we do our final fit up, because I also left these tenons slightly oversized. So I said that we were taking 3/8 of an inch off either side, but I left about a 32nd of an inch on each side that we'll go back in with my little block plane and trim off to make sure that we get an absolutely perfect fit into the mortises we're going to cut later on. So when I cut those mortises, I'm going to cut them to exactly 1 inch wide, and then I know that on these tenons, we're going to have a little bit of material to remove. And so the process for this, I've actually kind of dialed it in. While I was working on the other areas of this, I really, I thought about it, and it's going to be pretty easy to do it across the other 3 ends. So the first step is going to be finding the short end. So all I have to do is set my square up against one of the ends, and I can very quickly tell that this is the high end. So this is going to be the end that's going to have a longer part of the tenon. This end is going to be the short end because it's not actually touching the square right now. So I want to go off the short end because that's going to make sure that the minimum length on any of the tenon parts is 1 3/8, which is exactly what I want. This side's going to have a little bit more, so I can sand it off, I can remove it, but I'm always going to have a 1 3/8 tenon, so that's why I'm going to start on the short side. From there, I can mark in my 1 3/8 for my tenon. I've got a combo square already set up to that somewhere on the workbench here. So I mark that in, I mark that line. Then when I set up my jig, I measure out 2 and 25/30 because apparently that's the random number for the Bosch router from the edge of the base to the front end of the bit. That lines up perfectly, so 2 and 25/30. Measure out from that line, do my 2 passes on either side, make a mark at 1/2 inch and 5 inches in from either side. That'll give me my 1/2 inch space in here and then my 2 inch space in the middle. And then I can clear out all the waste with going between different saws and hand tools. And then finally finishing by chiseling out the waste on the ends here and just kind of squaring up the tenons in general. So overall, this really isn't that hard of a process. But doing this first one has taken me a long time. It's almost 11 o'clock today and I started this at about 8:30. So about 2.5 hours just to figure out how to do this. Now that I have it figured out, now we can just kind of get in a groove, do the other 3 ends, and it shouldn't actually take that much time. Okay, so first set of tenons, about 2.5 hours. Second set of tenons, about 15-20 minutes. So definitely a much easier process once you actually know what you're doing. It's way easier to knock things out. This is one of those things you gotta learn. The more time you spend woodworking is, the first time you do something, it's going to take a really long time. After that, it becomes, pretty quick and easy to do most things. So now that we have this board done, the most important part of this is to make sure that this internal length between this shoulder and this shoulder on the end is 81 inches, or really, 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 really close to that. And so if I screwed up somewhere along the line here and there's not 81 inches between the two shoulders here, it means that this bed frame is not going to be able to hold the mattress that it's supposed to. So I'm absolutely terrified to measure this right now. But I think we did pretty good. I know I took the time to measure it. I measured twice, cut once kind of thing. And, well, that's just darn impressive. We are precisely at 81 inches on this shoulder. So I'm going to flip the board over and just check the other side, just because we should be the same. But that's, yeah, we'll find out one way or another. All right, second side, and we are precisely on 81. So that tells me that both of our ends are now perfectly parallel with each other, and they are now perpendicular to the sides. We've got our joinery all squared up here, so it means that we should have no issues when we actually go to put this whole thing together. At least on this board. We still have one more rail to do before we can move on to actually starting to build the headboard and the footboard. Okay, so I am immensely impressed right now. Not only do we have thickness, solid 12-inch wide side rails, but we also have 4.5-inch by 1 3/8 inch tenons cut into them. And then our final check, I made sure to save it for on camera here like the other one. We are at close enough to 81. We're like maybe a 64th of an inch under 81. So it's real close, but yeah, I think I'm more than happy with that. Like I said at the very beginning of this, we can have some minor inconsistencies between the two side rails. That much inconsistency I'm not going to worry a bit about, because that's not enough that you would, it would actually skew the bed. That 64th of an inch between, over that whole length, you'd never even notice a difference. So we are perfectly ready to go with both of our side rails here. We've got all of our tenons cut. We still have a lot of cleanup work to do on these side rails, obviously. We don't want to leave all these ugly milling marks on here. So once we're actually done working with them and we're not moving them around the shop as much, then we'll go through and hand plane them. We're also going to add a very heavy round over to all the edges here. And then the last thing I decided I'm going to do is on all the edges of the shoulders of our tenon joint here. I'm losing my words because this was kind of exhausting to do. But anyway, on all of our edges down here, we're going to put a pretty good bevel on them. Somewhere between 1/8 of an inch and 3/16 of an inch, a pretty good bevel on there. Because what that'll do is it'll hide any of the inconsistencies we might have, and I think it'll highlight that this is a separate piece of wood. Because what we're going for on this bed frame is we want to make sure that it is 4 distinct pieces. So you have a headboard, a footboard, and then 2 side rails. So I think by adding that little bevel all the way around there, it'll create that little bit of visual separation. But the main thing is that it'll just help hide any inconsistencies that may end up in here. So that's going to be a really good touch, I think. Okay, so before we can move on with this project, we need to solve this issue of how we're going to cut these boards to length. Because obviously on those side rails, really no matter what I did, I kind of just had to use the circular saw, Buying a track saw was just kind of out of the question. I can't spend $1,400 on a project that is, I'm not even making that much money on it. So that's not an option. Buying a miter saw didn't seem like a good option then, but it does now, which we're going to talk about in just a second here. And so now I need to figure out if the circular saw is even going to work, because over that 12 inches that we were cutting before, there was a very obvious issue. But if we're only cutting 4 inches like we're doing on all these other pieces here, is there going to be as much of an issue? So I'm going to do a quick test cut on one of our pieces that I know is a little bit oversized. I'm just going to take a cut on it and just see if it's going to be an issue and if I need to explore this further. And so a very important point was brought up on yesterday's video by McCarthy Design. Maybe the causes of the issues that we were having on the rails there were caused by the blade vibrating as we were cutting through. Because cutting through 8/4 stock like this is no small feat. And you have to remember that the blade on a circular saw here is a very narrow very, very thin blade, you know, thinner than anything you'd ever put on your table saw. So as McCarthy Design pointed out, there's a very good chance that that blade is vibrating as it's going through, which is exactly what I thought was happening when I was making those cuts. So what I got in the habit of doing when I was trying to, you know, really get those cuts nice and accurate is I would take off the bulk of the material. And so then I'd finish it off by doing a half cut, so only using half of the blade. So again, this is a very, very narrow blade. I'm only making, you know, I was only making maybe a 32nd of an inch cut, if even that, and just slicing off that last little bit of end grain there. And so that in and of itself should eliminate any possibility of the blade vibrating, because if you're only cutting with half of the blade, that should be a small enough amount of material to completely eliminate that blade vibration, other than potentially maybe that blade vibration is just too bad on circular saws to be accurate whatsoever. So that's the real question we're asking here. And so what I found is even by doing that smaller half cut, I still got the same amount of error over my end. So now the real trick is that error the same over this small piece here? You know, this is only a little over 4 inches wide because I haven't cut it to width just yet. So we got just over 4 inches here. And now we're gonna find out if it's just over that 12-inch length that we had some error, or over this 4-inch length, because the trick here is that the back of the blade is only just barely gonna touch this side here. For the most part, we should be hitting nice and cleanly with only the front of the blade. So this is kind of the ideal solution theoretically for this circular saw, and for us to find out whether or not it is the back of the blade that's hitting and causing the issue, or if there is something else going on here. And so even without putting the square up to it, I know we're gonna have some issues, because the key sign here is that we have red paint on this top edge. So that means that somehow this top edge is contacting the body of this blade, because I've got a Frood blade in here, or Diablo, one of the red branded blades. And so the cut area of this piece should never, ever be touching the red part of the blade, because the teeth stick out proud of the main body of the blade. So if you're getting that red on there, that means that this piece of wood is contacting the backside of that blade. So that is kind of our key hint right there. So I'm gonna check it. I'm not expecting anything good from it. We're gonna check it vertically first. So vertically, we're actually worse. I don't understand what's going on. So that I can't explain, because when we cut the side rails, we actually, we were pretty square on the cut. I think what would be happening on the vertical here is because we have so little support with this 4-inch wide piece, is the saw might be rocking. So that's probably what's going on there. But now let's check. Let's check this. I can't check from this side because, like I said, this side is still rough. So we're only judging it from one side, and we can see the full width of it with the square here. So it's let's just get it over with. So it's basically exactly as bad as we saw on the side rails there. So we've got a big taper, and we've probably got at least a 32nd of an inch gap on this end here. So again, even though we're only cutting a short distance here, we can see just by the fact that there is that red paint on the end of the wood there, and when we put the square up, we have that pretty massive gap to it, that this is not going to be able to cut accurately. And so with the side rails, we were kind of able to work around this issue, because we knew that we were going to be cutting those tenons onto the end, and we could kind of correct things, minorly correct things as we went through and cut those tenons. Whereas with a lot of these pieces we now need to cut, the vertical legs, they need to sit flat on the floor, or at least, minimally have a wider section. I don't want only one corner of one of these legs to be actually contacting the floor, and then the rest of it not actually in contact. Not only is that going to be really bad for the piece of wood, but it's also going to be really bad for the floor. And so the other part of this is we need an accurate reference surface on the end of the board to measure all of our joinery up from. I'd just like to take this moment to say I'm a complete idiot. I'm really glad I didn't rush out and buy a $500 miter saw, because I can easily cut all of our leg stock on the table saw here. There's this whole right side of the blade. I, for some reason, had it in my mind that it's only a 36-inch table. No, the fence can go up 36 inches from the blade, but we actually have almost 50 inches from the blade to the wall, which means that our 47-inch long back legs are absolutely no issue to cut on here. and they come out perfectly squared up. The only issue is this crappy Craig miter gauge is not, it's got a lot of slop to it, so I just gotta make sure that I keep my hand nice and close to the blade, annoyingly enough. I just like to pause and show off my stop block there. Very high end, using both the wall and a couple of pieces of scrap. But we're going to be close enough to 47 inches even, and they should both come out to the exact same width. So that is all that matters in a stop block. Okay, so yeah, I was obviously an idiot. I didn't need to go out and buy a new tool to cut these to length. Clearly and obvious, anyone who has a table saw, anyone who is much more experienced in woodworking, probably smarter than I am. But anyway, I got them done. It's just one of those things. Sometimes you just have to struggle through to, get that in your head that, oh yeah, I've got this big expensive tool right here that does 99% of the things. Obviously, once we get to the headboard and footboard stretchers that are 6 feet long, that option's not gonna work anymore. We're gonna have to find some other way to do it, but that is a problem for another day. And the benefit with those is that we're going to be cutting tenons on the end, so it should be exactly like our side rails. So these are the only things that I wanted: a square top and a square bottom, and now they are perfectly square, top, bottom, sides, everything. All about these are perfectly milled up now and ready to begin some joinery on them. Okay, so that is all we're gonna be able to get done today. I'm very quickly running out of time in the shop here. I still gotta get this video edited today. And so we've got all of our mortise locations laid out here, and so this actually went a lot smoother than I even thought it would. Now this is exactly how I was planning to do this all along. I knew that I'd be able to just transfer the exact width of each tenon that we cut on those side rails onto these just using some green tape. So now we know that the width of each of these is the widest point on any one of those tenons. So they should slot in there just perfectly once we clear out this material. But like I said, when we cut the tenons, we will still have to thin them down to actually fit them into this 1 inch space. I'm also gonna have to make a run to Lowe's tomorrow to actually go get the bolts, because before we can actually build these into the headboard and footboard, it makes a lot of sense to do all of our drilling while we can still put these in a drill press. Once we have a whole headboard and footboard attached to each of these pieces, it's going to be nearly impossible to take it over to a drill press. And so I do hope you guys enjoyed the video today. That was definitely a very interesting learning process, a lot of ups and downs. That's kind of what it's been so far the whole time with this project. And like I said at the very beginning, the most challenging thing about building a bed frame is not all the joinery and the stuff that goes into it. It's just the sheer scale of a lot of these pieces. It's a lot more challenging to figure out how to get accurate cuts, do your joinery and all that, just because these pieces are so large. But there's still more to come to this project, and I feel like it's just going to keep getting more interesting. So guys, I do hope you enjoyed this video. If you're interested in picking up some of my merch, you can feel free to check out my website where I have all the different shirt designs there. There will be a link to that at the end of the video. And as always guys, I do hope you enjoyed this one, and I will see you in the next one.